Yesterday, we introduced you to the steps involved with linear programming problems to be able to use these steps and apply them to real-world applications so we can figure out some maximizing and minimizing problems. Today, we're going to take a look at some actual examples. But before we do so, I want to refresh your memory to remember that first, our step one is going to be, let's define the variables, tell us what x and y are, and remember, if you take a look at what the problem's talking about, what the problem asks, it will tell you what your variables represent. Second, we're going to write a system of inequalities that describe the constraints. Step 3, we'll graph the resulting system of inequalities. Step 4, find the corners of the region. I know the one in the example yesterday was a little bit challenging because you didn't graph it yourself. However, today I will show you how you can find those intersections. 5, write the equation you want to maximize or minimize based upon the information in the problem. Step 6, substituting the coordinates of each corner into the equation from step 5. And 7, selecting the appropriate result based upon your results. We're going to have a couple videos here going through one example that, like I said, they're not difficult problems, they're just a little more involved. So our problem we have here is this. We have a tourist agency. They can sell up to 1,200 travel packages for a Vikings football game in Seattle, Washington. The package includes airfare, weekend accommodations, and the choice of 2 types of flights, a non-stop flight or a 2-stop flight. The non-stop flight can carry up to 150 passengers, and the 2-stop flight can carry up to 100 passengers. The agency can locate no more than 10 planes for the travel packages total. Each package with a non-stop flight sells for $600, and each package with the 2-stop flight sells for $400. We want to assume each plane will carry the maximum number of passengers, in other words, it will be a full flight. And we need to determine how many of each flight the tourist agency must sell to maximize their revenue. So if we start with step 1, and we need to define our variables. When I look into this problem, I see that we've got some valuable information, so let's go ahead and highlight that. We've got 1,200 travel packages total. Then we have a bunch of information that's not really all that important. We have a non-stop flight that can carry up to 150 passengers. The 2-stop flight can carry up to 100 passengers. No more than 10 planes can be located for the travel packages. And non-stop flights sell for $600. And 2-stop flights packages sell for $400. And so we need to incorporate this information, and I'm noticing that the 2 things we're consistently talking about here are non-stop flights and 2-stop flights. So I know that those are what my variables must represent. So I'm going to let x represent the number of non-stop flights, and we're going to let y equal the number of 2-stop flights. So then we move on to step 2, which is probably for most of you the most difficult part. For most of these, you will have 2 inequalities that are given. And one of those is that x will be greater than or equal to 0. And that's because we can't have a negative number of nonstop flights. There has to be 0 or more. The next one would be y is greater than or equal to 0, because likewise we can't have a negative number of 2-stop flights. Now, one of the next things they talked about was that we can locate no more than 10 planes, in other words, no more than 10 flights. So I know that that means that my x and my y added together, so flights plus flights, has to be less than or equal to 10 because we cannot sell more than 10. Now the final one is the one that's probably the hardest one to find. I'm going to deal with the cost piece when we talk about maximizing revenue, which is until step 5. So we need to deal with those passengers. Well, if we can put 150 passengers on each nonstop flight plus 100 passengers per of 2-stop flights, that they said they can sell up to 1,200 packages. So we can't have more than 1,200 packages. So that's going to be less than or equal to 0. So now we have our system of equations. So in the next video, we're going to look at how we graph those.